Hey folks, welcome to another set of Chemistry 1 video notes. In today's lesson, the second lesson of Unit 4, you'll be learning about empirical formulas in percent composition. More specifically, we'll be covering C.4.6 and C.4.7, which ask you to be able to perform calculations to determine the composition of a compound or a mixture, given the necessary information, and to apply lab data to determine the empirical and molecular formula of a compound. That being said, let's get started. Right out of the gate, you should easily be able to find percent composition. It's a simple ratio of parts to a whole. I'm pretty sure you've probably done something similar in math class before. So, imagine I have this mixture here to the right. Say I mix together 504 grams of H2O, 92 grams of sodium, and 142 grams of chlorine. How would I find the percent composition? Well, first you find the mass of the whole mixture. In this case, 504 plus 92 plus 142 gives you 738 total grams of mixture. Next, you take the mass of your single part divided by the mass of the whole mixture. So, if I wanted the percent composition of water in this mixture, it'd be 504 divided by 738. This gives me about 0.683. Multiply that number by 100% and you'll find out that water makes up 68.3% of this mixture. Go ahead and take a moment to calculate the percent composition of sodium in your notes. I will be checking them 4 points when I grade your notebook, so make sure you show all of your work. What if I gave you the percent composition and asked you to find the mass of each part? Could you do that? Well, with a little bit of algebra, you could rearrange your equation to look like this. So say I knew that chlorine was 19.2% of the mixture that we talked about before. I'd divide that percent composition by 100% to get the simple ratio, and then multiply that number by the mass of the whole mixture, 738. This would give me about 142 grams if I were to round. Before we go too far, let's get some background information in. One of the very most important units that you'll ever learn about or use in chemistry is the mole. It's simply a unit. It has a weird name and we make a lot of funny jokes about small rodents, but it really is just a unit. The mole helps us find how many particles of a substance we have. In every mole of any substance, there are always exactly 6.022 times 10 to the 23rd particles. I like to think about the mole as a box of donuts. We know in the back of our mind that a box of donuts from the grocery store usually has about 12 donuts in it. Sometimes 13, but for our sake, let's say 12. Instead of saying, I bought 12 donuts today, it's sometimes easier to say, I bought a box of donuts, or I bought a dozen donuts today. That's all a mole is. It's sometimes called the chemist's dozen because it's just a different way to count how much we have of something. The mole is really important in chemistry because we can't count each individual particle we have and know exactly how a reaction will take place. It's basically impossible. So what we can measure really easily is grams. If only we had a conversion factor from grams to moles. Oh wait, we do! It's called the molar mass. The molar mass of a substance is how much 1 mole, or 6.022 times 10 to the 23 particles of that substance, weighs in grams. So how do you find the molar mass? Easy peasy lemon squeezy, my friends. You simply add up the atomic masses for each of the atoms present in your molecule. On the periodic table, the atomic masses are represented in AMUs, or atomic mass units. When we have 1 mole of a substance, 1 AMU is equal to 1 gram. So, let's do an example. Say we have H2O. That's 2 atoms of hydrogen and 1 atom of oxygen. On our periodic table, it says the atomic mass of hydrogen is 1.008 AMU, and oxygen is basically 16. So to find the molar mass of H2O, you'd add up 1.008 plus 1.008 plus 16. That tells you that every mole of water weighs exactly 18.016 grams. The unit for this would be grams per mole, so 18.016 grams for every 1 mole. So, how do we find the percent composition of a substance? Well, I'm glad you've asked. Here you thought this would be really hard, but it's actually just the same thing we just learned about finding the percent composition of mixtures. So you would take the total mass of that element that you're looking for in your molecule and divide by the total mass of the whole molecule, then multiply by 100%. So if we wanted to know the percent composition of hydrogen in H2O, we'd find the mass of all of the hydrogen in H2O, so 1.008 plus 1.008 gives us 2.016. Then divide that by the molar mass of H2O, which we just found was 18.016. This would give us a ratio of 0.112, and then we multiply that by 100% to find that hydrogen makes up 11.2% of a water molecule. All right, one more extra nugget of learning before we hit our last two big concepts. The difference between an empirical formula and a molecular formula is that the empirical formula gives you the simplest whole number ratio of elements in a substance, while a molecular formula tells you exactly how many atoms of each element are in each molecule. For example, CH is the empirical formula for both benzene and acetylene. These are two very different molecules, though. Benzene has 8 carbons attached to 8 hydrogens, while acetylene only has 2 carbons attached to 2 hydrogens. The simplest ratio is still 1 C for every 1 H, but molecularly it looks a lot different than that. Glucose has a molecular formula of C6H12O6, but its empirical formula, the simplest ratio, would be CH2O. The empirical formula and the molecular formula is not always different, such as in water's case, but the molecular formula is always the same, or at least a ratio of, the empirical formula. If I'm given the percent composition of different elements in a compound, how can I find the empirical formula? You just use all the information we learned before with a couple extra tricks along the way. To make things easier, when you're given the percent compositions of each element in a substance, just pretend you have 100 grams of that substance. To do that, you can easily assume that each percent value is now how many grams of each substance you have. Next, divide each element's gram value by its molar mass, or atomic mass, that you find on the periodic table. When you do this, you're actually setting it up like a conversion, which we'll see in a minute. This will tell you how many moles of each of your element you have. So next, divide these molar numbers by the smallest mole number that you just got, and round to the nearest whole number. This will give you the molar ratio of each element to itself. These molar ratio numbers will now become your subscripts in your empirical formula. If you've got extra time and want to double check your work, start with your empirical formula, find its molar mass, then find the percent composition of each element. This should give you the same percent composition values that you started with. Let's go do an example. All right, so our first example says that we have 85.63% of carbon and 14.37% of hydrogen. So find the empirical formula. So like we said, we assume these are grams, and we divide by the atomic masses of each of these elements. So if you look at the periodic table, carbon is 12.011 and hydrogen is 1.008. When you do that, you get 7.13 and 14.26. Next, you divide by the smallest of those two numbers, and you get 1 and 2. So your empirical formula is going to be C1H2, or just CH2. So for every 1 carbon, we have 2 hydrogens. Now remember, this is the empirical formula, which only tells us the simplest whole number ratio, so 1 to 2. Well, now you're probably thinking, well, that's great and all, but what good is the empirical formula if we already learned that it only tells you the simplest ratio? Well, that's a great question. One empirical formula could stand for dozens of different molecules. So how can we go from here to find the molecular formula? Well, the short answer is you can't, unless someone was kind and generous enough to tell you what the molar mass of your actual substance is. If you're given the molar mass of your substance and the percent composition of each element, simply follow all those steps we just did and then find the mass of your empirical formula. Next, divide your actual molar mass by the empirical formula's mass that you just found. This will give you the whole number ratio of the molecular formula to the empirical formula. Use that ratio to multiply it by the subscripts of your empirical formula, and now you have the correct molecular formula. If you want to check yourself on this, calculate the molar mass of your new molecular formula. It should be the same as the molar mass you were given. Let's go do an example of that. Okay, so now the author of this question tells us the molar mass equals 56.108 grams per mole. So the first step to figuring out what the molecular formula is take our empirical formula and find its mass. So we have carbon, which is 12.011, plus 2 hydrogens, which gives us 14.027. And then we take our molar mass divided by this number, and it gives us a ratio of 4. What that means is the molecular formula is 4 times the empirical formula. So this time it'll be C4H8, because 4 times the 1 is 4, and 4 times 2 is 8. Now if you want to double check your work here, go ahead and find the molecular mass of C4H8. That'd be 4 times 12.011 plus 8 times 1.008. Then I'll give you a molecular mass of 56.018. And that's right, because that's what it told us it should have been. Well, that's all for today, folks. I hope you were able to learn something from this notes video. As always, if you have any questions, ask.